I am Anil Kumar. Welcome to my series on linear equations. We'll try to understand how to solve linear equations with the help of 8 examples given on this page. We'll take these examples one by one in a minute. Let us first understand the terms. The question here is solve and check linear equations. Right? So that is the question. Now, solve means find value of the unknown. So let's write down the meaning of solve first. Solve means find value of variable. In this case, variable is x, so that the equation is true. Now, when I say equation is true, what does that mean? That really means that left hand side is equal to right hand side. So every equation has two sides. One on the left side of the equal to, so we'll call this as left hand side. The other one on the right side of equal to sign. So they should be equal when we say that the equation has been solved, right? And solving really means to find the value of x which satisfies it. So we'll learn the technique of solving, and once we have solved, we'll also check our result. So we'll do it in two parts. Now, when I say linear equations, what does that mean? Linear equations mean that every equation will be of the form where x will be unknown. Instead of x at times, we may use other letters. For example, we could have p, q, or any other variable, but the power here is always 1. So linear will mean that the degree of equation will be 1. Correct? So when I say 1, it means we'll just write it x. X, anything to the power of 1 is x, right? If I have x square, it is called quadratic. Degree is 2. So that is to kind of differentiate between what is linear and what is non-linear. So x square will be non-linear, right? So linear is x, and if I say non-linear, it will be x to the power of n, right? Where n is not equal to 1. Correct? So that is how we could actually define linear and non-linear. Now let's begin with the very first question and see how to solve it. We are given that x minus 8 is equal to 12. Now equal to is like a balance. So what we can do here is that we can add same terms on both the sides. So in this particular case, since we have minus 8 extra, we can add 8 on both the sides. So when you add 8 on both the sides, what do you get? You get x minus 8 plus 8 is 0, 12 plus 8 as 20. So we say that our solution is, in the short form I'm writing, x equals to 20. And now the next portion is to check. So when you want to check, you say, well, on the left hand side, what do we have? On the left hand side, we have x minus 8. So instead of x, if I write 20 and do 20 minus 8, I do get 12, and that is equal to right hand side. So we have checked that it is correct. Is that clear to you? So that means x equals to 20 is the correct solution. Perfect. Let's apply the same method in the next question. Now, in the next question, what we have is x plus 6 equals to 9. We need to basically isolate x, right? So basically, we have to isolate the variable x. So we have 6 extra. So we have 6 extra. We'll now take away 6. If I do minus 6 both sides, I can solve. Does it make sense to you, right? So that is the kind of strategy which we are going to use. So let us take away 6 from both the sides. So if I do minus 6 on both the sides and then add it up, what do I get? I get x is equal to, because 6 minus 6 is 0, 9 minus 6, which is 3. So we have a solution again. We can write this solution as x equals to 3. Now let us check it as we did earlier. So on the left hand side, I'll substitute the value 3 for x. So I have 3 plus 6 as equal to 9, which is equal to the right hand side. So we have once again have left hand side equals to right hand side for x equals to 3. And therefore, that is the solution. Correct? So x equals to 3 is the solution, and that is the correct solution as we have checked our result. Clear? So that is how we are going to solve the equations. Now, the method is kind of similar when we have product. So we have this question which says 3x is equal to 15. So basically, if you see, we did the reverse operation, correct? So here, what we did was reverse operation. The reverse of subtraction or a minus is positive. Reverse of plus is minus. So we did the reverse operation to isolate x. That is what we are going to do here also. So what is the reverse of multiplication? So here we have times, right? So we have to do division. And that is what we say reverse operation. Is it clear? So 3x equals to 15. What we are going to do here is that both sides we are going to divide by 3. So if I divide by 3, we can get rid of this extra 3 as coefficient of x. And on the right side, we get 5. And so we could write this as x equals to 5 as our answer. Is that clear? Now once again, let us try to check our result. Check really means we'll substitute the value of the answer on the left hand side. So on the left hand side, we have 3 times 5, and that is 15, and this is indeed equal to right hand side. So we have shown that the left hand side and the right hand side are equal, and therefore the answer, which is x equals to 5, is correct. Perfect. So that is how we are going to do it. So once again, the next question here is 2 over 3x is equal to 8. Now what is reverse of 2 over 3? So let's look into it. We have 2 over 3x equals to 8. The reverse is 3 over 2. If I multiply this by 3 and divide by 2, I get rid of the coefficient of x. Now, since there is an equation, we have to do the same thing on both the sides. So that is important concept. So always we do the same operation on both sides. To get the correct result. Perfect. So that is how you're going to do it. Now, as you can see, we can cancel away 3's and 2's. We are left with x on the left hand side, and we can simplify the right hand side. On the left hand side we have x equals 2, and there we go. 8 times 3 is 24, divided by 2 is 12. Or you could also simplify by cancelling, and 4 times 3 is 12. And now our solution is x equals to 12. And that is our answer. Correct? So we have done the first part of the question. Now we need to check our result. To check, on the left hand side, we'll substitute the value of x, which is 12. So we have 2 over 3 times 12. And when you multiply, you get 4 times 2, which is 8. And this is equal to the right hand side. So we have again shown that left hand side is same as right hand side, and therefore the solution is correct. Perfect? Now let's take the second question, rather the fifth question, which is 2x minus 3 equals to 7. I will now like you to pause the video, answer this particular question, and then look into my suggestions. So first step is to copy the question, which is 2x minus 3 equal to 7. And now we have to do the reverse operation. So in the reverse operation, what should you do first? So we do reverse operation in reverse order. In reverse order, what do you understand by that? I hope you remember order of operation, right? So we'll go with order of operation, which is BEDMAS. But we are going to do this order in the reverse operation in the reverse manner. So first step is to take care of numbers which are added or subtracted. So in this case, minus 3 is the number which is being subtracted. So we'll first reverse this, right? So I'm going to write it in a different way now. So we have 2x minus 3. We are going to add 3 on both the sides, which I'm now writing in a linear form, in a straight line. So what we get here is 2x is equal to 10. And now we can divide by 2 on both the sides. So we get 2x divided by 2 equals to 10 divided by 2. So the x value is 5. So we have our answer, which is x is equal to 5. So that is the first part of getting the answer, which is x equals to 5. And now we need to check our answer. Check really means we'll begin with the left hand side. In our case, the left hand side is 2x minus 3. We are checking for x equals to 5. So we'll substitute 5 here for x. What do you get? 2 times 5 is 10. 10 minus 3 is indeed 7, which is same as the right hand side. Do you see that? So we have shown that the left hand side is equal to right hand side for x equals to 5, and therefore x equals to 5 is correct solution. Is that clear to you? Now these are the real steps which you should be doing in solving any test questions, right? So at this stage we have understood that to solve a linear equation we have to do the reverse operations, and these operations are also done in reverse order. Order as being shown here. Do you see that? So we'll begin with subtraction and addition, then multiplication, division, right? That is how you have to do it. Let's take up practice question number 6. I'll now like you to pause the video, find the solution, and then check it. So the question here is 1 over 3x plus 2 equals to 1. First thing, we have to get rid of 2 from here. How do you do that? Well, it is plus 2, so we'll take away 2 from both the sides. When you take away 2 from both the sides, you get 1/3 of x as equal to minus 1. Now, we will multiply by 3. So when you multiply by 3, you get x equals to minus 3 as your solution. Is that clear to you? So you could get a negative answer also. You could get answer in fractions or decimals also. Now, let us see whether this solution is correct or not. So we'll call that process as checking our answer, which is x equals to minus 3. The question was 1 over 3x plus 2. This is our left-hand side. So in the left-hand side, I'm going to substitute x equals to minus 3. So we have 1 over 3 times minus 3 plus 2. And that clearly is minus 1 plus 2, and that is equal to 1. So in each stage of our solving, we figure out that it does give us the right hand side, which is 1. So we have shown that the left hand side is equal to right hand side, and therefore this is the correct solution. Perfect. That is how you're going to do it. Let's take up the next question now, which is 3x minus 5 equals to 7 plus x. So let's rewrite this question. 3x minus 5 equals to 7 plus x. Now at this stage, we are going to solve the question in different steps. So sometimes we also call this as multi-step, right? So let's write down. It's called multi-step solution. Correct. So in the very first step, we have x on both the sides. We could bring it together, right? So let's bring x on this side. So I could write this as 3x minus 5 minus x equals to 7 plus x minus x, right? So that gives us 3x minus x as 2x minus 5. So I'll write this as 2x minus 5 equals to 7. So here, first we simplified and we got x on the left hand side, right? So we put x on the left hand side. And now we'll isolate x. To isolate x, we'll have to add 5 first. So we'll add 5 on both the sides. We get 2x as 7 plus 5 is 12. And now we are going to divide by 2 on both the sides, which I could also write as this. That is x equals to 12 divided by 2, which is 6. And so we do get our solution, and we'll write down the solution as x equals to 6. Now that becomes our solution, but we need to check it. How do we check? On the left hand side, I'm going to write down x equals to 6, right? So on the left hand side, we'll use x equals to 6, which is 3 times 6 minus 5, and that is 18 minus 5, and that is equal to 13. Now we also have on the right hand side x, right? So let's also do the right hand side. On the right hand side, we have 7 plus x. X is 6 for us. And when you add 7 and 6, we do get 13. So we realize that left hand side is indeed equal to right hand side. And that is what we mean to check. Is that clear to you? So if you have variable on both the sides, this is the way to solve it. Here is the last question for you, in which it is kind of a fraction. I've seen that sometimes students are scared with fractions, but we'll show you another very simple technique of solving such questions. I call this as cross multiplication. The question is 3x plus 1 divided by 2 equals to 7. We can actually multiply both sides by 2. So if I multiply by 2 on both the sides, on the left hand side, the denominator 2 cancels with the term 2 multiplied with. And so what we are left with is the numerator 3x plus 1 and 7 times 2 as 14. Now it is like a normal equation which you have solved earlier. We'll follow the same steps. So first step will be, we'll take away 1 from both the sides. When you do that, you get 3x is equal to 14 minus 1, which is 13. And now we are going to divide by 3. So we get 13 divided by 3 as our answer. So we could have fractions as our answers also, as we have in this particular case. And now let us check our result. In this case, we will just begin with the left hand side and we'll show that this is equal to 7. So on the left hand side, what do we have? We have 3 times x, which is 13 over 3 plus 1 divided by 2. And that gives you 13 plus 1 divided by 2, since this 3 cancels with the other 3. And so what we see here is 14 divided by 2, which is 7. So we have shown that the left hand side is equal to right hand side. Perfect. And that is what we call checking the result. Perfect. So with these 8 examples, we had a variety of linear equations to solve. So let's have a close look at what we have just done. So in the very first case, it was kind of simple. You could have done that part also by intuition. So you could, or trial and error. So the other methods could be intuition. Sometimes we also use methods like trial and error. So just try out few numbers to get your solution. However, what we focused on was the algebraic steps. Steps involved reverse operation, right? So that is the key to solve linear equations. I'd like you to go through this once again and understand the steps involved. So first few questions were simple, but then soon we had examples with x on both the sides. And such examples, we have to substitute x on both the sides to verify at the end to check the result. We also learned a technique of cross multiplication which can take care of fractions while we solve linear equations. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.